Hey everyone, it's Dan, and today we're going to talk about relays. Now this is a standard 12-volt automotive relay. All it really is an on-off switch. Not all that different from the light switch that you have at home. Really the only difference is instead of physically toggling something on and off, you're applying a small amount of energy to the relay to turn something else on and off. So relays have a lot of different uses. Most often I tend to use them to control the power to accessories for my motorcycles and cars. So for instance, I may want to turn some lights on or an amp or heated seats or heated grips only when the ignition is turned on. So that's the perfect case to use a relay. You don't have to worry about forgetting to turn it off when you walk away from the bike or from the car. Now, the way that these are wired is pretty standard, and all of them always have either a printout or an embossed circuit diagram of how the thing actually works. And it's always pretty standard. So the pins are labeled with numbers on the inside so that you know how to correlate the pin that's actually on the contact to the printout that's on top of it. So pins number 85 and 86 always control the relay. So when you apply power between 85 and 86, or when you apply voltage between 85 and 86, it'll energize the relay, it'll close the switch, which effectively is the same as flipping on your light switch at home. When you remove power between 85 and 86, it'll de-energize the relay and effectively flip the switch off. Now the other important terminals on the relays are number 30 and 87. That's where you're actually controlling when you apply power to it. So an easy way to think of it is by having two wires. When you energize the relay, the two wires close, so that's 30 and 87. When you de-energize it, the switch opens again, so you disconnect those wires. Some relays may also have a fifth lead over here, that's 87A. That one is on or connected by default, and when you energize the relay, it disconnects. Usually it's not used as frequently, but it does give you more options if you want to do that. Relay installation is made a lot easier if you use one of these harnesses that you can easily buy online or at an automotive store. This just makes installation a snap. You hook up the wiring, and then you're easily able to plug in the relay, snaps right in, and then replace it if it ever goes bad. Now you've got to pay attention to the coloring. So typically the black and the yellow are the ones that actually control the relay. So when you apply power between those two or connect them to a battery, it'll energize the relay, it'll close the switch, and effectively it'll connect the red to the blue on the outside. So the red cable you would want to connect to a constant power source like your battery, and the blue cable would then go to whatever it is that you're controlling. So when you turn the ignition on, it'll apply voltage between the yellow and the black, which will close the switch inside of the relay, and then effectively the red cable and the blue cable are connected because of the switch that's inside and close the circuit for you. So let's take a closer look. I'll use a DMM, or specifically the ohm or resistance reading. If you're not sure what that is, it's just a measure of whether a circuit is open or closed, and if it's closed, how much resistance there is between the wires. So for example, if I just connect two of them together, the reading changes from overload or very, very high value to 0 or almost 0 ohms. So 0 ohms means that the two cables are actually connected. So we're going to use this to check the relay and make sure that it works as we expected. If you recall, the red and the blue cables on this harness are the ones that are actually being controlled. So I'll connect the red one to one terminal of the DMM, the blue one to the other. So as you can see, there's no change. They are not connected. The relay is not energized. Nothing happened. But if I now connect the blue or the black and the yellow terminals to the battery, then we expect to see a change when the relay is energized. So I'll connect one, and then if you listen carefully, you'll hear a click. And if you noticed, the ohms reading also changed to be a very, very low, meaning that there's very little resistance, or the cables are effectively connected. Now, if you have a relay that also contains a fifth terminal, or the white wire, it'll work the opposite way of the way that blue and red works. So if I switch the blue one and connect the white one instead, you'll notice that the resistance reading changed. So by default, when the relay is not energized, it's reading a very low resistance value, meaning that the switch is actually closed. Now, if I control it again, so again, black cable to the negative terminal, hear the click, and the reading on the DMM changes back to an overload, meaning that the circuit is open. And then every time you connect or disconnect relay, you will hear a click. So that's an easy way to tell whether it's actually working as expected. So I hope you found this video helpful. If you do, please give it a like. Be sure to subscribe to the channel, and I will see you next time.